Hello everyone. This is our final year BE project, and our project is titled as SimuTwin, which is an anomaly detection in water treatment plants using a digital twin. Our mentors are Dr. Sangeeta Oswal and Mrs. Samruddhi Yeole, and our team includes of Ashish Patil, Riya Khetani, Shreya Pavaskar, and Atharva Bharti. So our project is focused on creating a digital twin to simulate and detect anomalies in water treatment processes. So, what are digital twins? A digital twin is essentially a virtual copy of a physical system, which receives real time data from sensors from the physical part and updates itself accordingly. It allows us to simulate various conditions and observe the system's response without any risk to the actual physical infrastructure. So, as defined here, this digital twin helps us to monitor, analyze, and optimize the real world system by simulating its behavior under different conditions. One of the perks of using a digital twin for a system is that we can simulate different scenarios. So, we do not have to uh, make changes in the physical system to see how the system responds to it. Instead, we can do those changes in the digital twin virtually and see how our system adapts to it. If the adaptation is good, then we can implement it on the physical system. So, how does a digital twin work? A digital twin works by continuously collecting data from the sensors of a physical system. The sensors collect data from the real object. Then, this data is sent to the digital twin in the computer. Then, the digital twin behaves like the real system, allowing the people to monitor and test changes. So, when the digital twin mimics the physical system, we can change the values, we can change the values of particular sensor and see how our system adapts to it rather than changing it physically, which can have a physical impact and which is not very cost effective, which again allows us to simulate different scenarios without affecting the real world system. Next, why digital twins? Now, as we can see here, digital twins improve efficiency, reduce costs, and enhance decision making in various industries. They can predict failures before they happen. It allows us to test changes before applying them in real life and enhance safety by identifying risks in advance. And it also helps to reduce environmental impact. So, these are the several areas where digital twins are made. Moving to the problem statement, we use the SWaT dataset, which is Secure Water Treatment Dataset, which is a dataset collected from a water treatment plant developed by itrust. It simulates real-world water purification process and contains records of how the system behaves under normal and attack scenarios. However, the challenges include real time data synchronization, where continuous updates are needed to reflect the physical system state accurately. Another is data integration. As the SWOT dataset includes diverse sensor types, it requires seamless integration into a scalable digital twin model. And next is anomaly detection and prediction are essential to identify abnormal readings or potential system failures or attacks in real time.
Okay, so this is the code which hosts our server, and the server hosts our model. So we expect the data in the order that we have specified over here in the sensor order array. Uh, After that, what we do is we load the model using the load model method. Our model is in the form of .h5, as you can see over here. So we receive the data in the form of JSON, and we use a min-max scaler to normalize it. So what we do is we first extract the features out of the JSON body and verify that they are 100 because the model requires 100 time steps. We convert it into a NumPy array, and then we normalize it using the min-max scaler. After that, we reshape the array according to the specifications of the model, which is of 1 into 100. After that, we pass that array into the model, and then the model gives out probabilities. So for example, if the scenario is of attack, then the probabilities are close to 1. Otherwise, the probabilities are close to 0. And that's what we send to the front end as a HTTP response. So this is the front end, which shows all the sensor in the grids, and as you can see, the sensor values are updating in real time, and they are fetched from a CSV file. Also, as you can see in the bottom, there are certain values, and those values show which sensors are defaulting at this moment, and we are just using an if else or a rule based system to define that. So if a sensor is out of its normal operating range, then we indicate it over here, and that's how we diagnose what's wrong in the system.
Now, as you can see, these are the results which we have achieved. Furthermore, thank you for our project.